5 ways to reduce fall hazard risks, presented by Kevin Wilcox. Next slide, please. I do want to let everyone know they have been muted for audio quality. This webinar is also being recorded, so you may access it at a later date. I do want to let everybody know, if you do have any questions during the webinar, please feel free and type them into the chat box, and we'll go over them during the Q&A portion of the webinar. Next slide, please. I would like to let everyone know that the FMCC provides many services to the FM community, such as Ask the Expert, Find a Consultant, Locate a Speaker, and online educational resources. You may find more information at their website, fmcc.ifma.org. Next slide, please. And next slide, please. I would like to take this time to go ahead and thank our sponsors for sponsoring these webinars and the FMCC. And the next slide, please. I do want to let everyone know that when you exit the webinar today, there will be a box that pops up asking you to take a survey. I do encourage you to take that post-webinar survey, as the FMCC board and the STAG team do look at those results and eagerly anticipate your feedback. Next slide, please. Okay, and the next slide. Okay, at this time, I would like to go ahead and introduce our presenter today. Kevin is a principal of the LJB, Inc., and a professional structural engineer who is also a certified safety professional. He has more than 20 years experience in fall protection consulting, with expertise in fall hazard assessments, design and inspection of fall protection systems, and related training. Fall protection prevents two conflicting realities. Significant fall incidents don't happen often, but when they do occur, they're catastrophic and costly. The challenge, however, is that fall protection is complex. There are numerous regulations, standards, equipment options, training resources, and priorities to consider when protecting workers at heights. Kevin approaches fall protection in a practical way to minimize the complexity, while taking comprehensive action to protect people, projects, and businesses. At this time, I'd like to turn it over to Kevin.
All right, well, thank you very much, Josh. I appreciate that introduction, and welcome everybody. I hope we can have a little dialogue here today, and I know it's going to be a lot of me talking, and I will try not to tell any jokes that I won't have any idea if you're laughing or not. So bear with me if I slip into my comedian mode. I've been told I'm quite funny, actually, but we won't find that out today. So hey, the learning objectives that we wanted to address today are sort of short and sweet. We want to be able to list 5 different ways to reduce fall hazard risk, and then be able to explain those same 5 ways, to describe the differences between a certified and non-certified fall protection system, and then lastly, to be able to summarize the critical elements needed for effective fall protection training. So what we've found is there's multiple things that we can do to reduce fall hazard risk. I'm going to be talking about 5 of some of the, I guess we're calling them the top 5 ways, but certainly there are other things that can be done. But first I wanted to sort of give a little background from my perspective on why do I think this is important, or at least why is it important to me. We all, in our careers, we all feel like we want to make a difference, right? We want to have an impact, to know that what we're doing is important. And so let me tell you a quick story about what brought this whole idea of fall protection to life for me. So my background, as Josh said, I'm a structural engineer. In college, right, young structural engineer kids were thinking we're going to design the next high-rise, or actually I remember sitting in a lecture with my buddies, and we were brainstorming about how we were going to design the next, or the first, lunar space station, some big structure on the moon. Right, so we have these grand ideas of being structural engineers, and of course I come to work at LJB 20-some years ago, and we were getting into fall protection. And of course, as a structural engineer, we're all thinking, well, that's safety. Why are we doing fall protection? Turns out there is a lot of structural engineering that's required for fall protection. We'll talk a little bit more about that. But what's neat about it for me is I've been able to go to a lot of really interesting places in my career, and I'm not going to give away the secret of where this particular place is that you're seeing on the screen right now. But let me tell you the quick story about how it brought fall protection home for me. So we were called, this is the roof of a building, and we were called to certify an anchor, certify a bunch of anchors as a matter of fact. One of the employees of this agency, this organization, had gone to some fall protection training class, and in that training he learned that their anchors ideally should be certified. And so he took that information back to his supervisor and said, hey, have our anchors been certified? And it turns out they really didn't have any sort of evidence to say they were certified, and so this organization called our company and said, come out, we need you to certify our anchors. Well, what certification really means, and we'll talk more about this in a bit, is that you have the proper documentation to back up what you're claiming the system can do. And so we asked for the documentation. So what do you have? And what they gave us was a fairly decent design drawing of the fall protection system, the anchors that were to go on the roof, and it showed what you're seeing on the screen here, this big plate. It's about a 12-inch square plate installed into this concrete wall with some adhesive anchors. And what they lacked was any evidence of how those adhesive anchors were actually installed into the concrete wall. In theory, we ran some numbers and it should work. The structure should be fine. The adhesive anchors were properly designed. Everything would be just fine. One flaw they did have was, you might be able to tell here, this is an eye bolt, and on the right-hand side of the screen is actually the roof edge. The idea is they would clip off their vertical lifeline to this eye bolt and go over the roof to do facade maintenance, which when they do that, they were going to load that eye bolt in sideways, which is not the strong direction of that eye bolt. So that was certainly a problem that they were going to need to correct. But beyond that, in theory, everything was okay. However, since we didn't know about the installation of the adhesive anchors, we thought, well, let's validate things by doing some load testing. And so what you see here now is a setup that we had on the roof of this building to do some pull tests on these anchors just to validate that everything was fine, and nobody really had any reason to suspect anything different. But what you can see is this chain, and in line with the chain is a pneumatic, or I'm sorry, is a hydraulic pump that put tension on the chain, a dial indicator there to indicate if the plate was moving. Of course, nobody expects it to move, and so we're up on the roof just kind of making small talk while the guys running the tests are cranking on the load, and then suddenly, bang, right, it pops. Here's a view of the top of this anchor, and I need to point out it didn't fail because we loaded it with 4 times the expected load. It actually failed at about 1/3 of the load that would have been applied if somebody were to fall while using that anchor. So that told me that if somebody actually were to have used this anchor and fallen, they might very well have hit the ground and died. There's a 6-story building. That's why, for me, this is a very important topic, that we make sure that we help to spread the word and to educate folks that have any kind of interest and need for providing safe ways for people to work at height. We want to help you do it as safely as you possibly can. Here's what happened. In that wall, there were remnants of the formwork that were left in place. This wood block, this is the bolt that was installed in that, supposedly installed in the concrete wall. Nobody really knows what happened that day that the contractor drilled the hole in the concrete. He was drilling hundreds of holes to install all these anchors. Came across this one, and actually there were others that subsequently we've discovered where it wasn't installed into concrete. It was installed into a wood block. Nobody knows why. Nobody knows if it was the contractor, the installer himself, who said, it doesn't matter, or maybe he reported it to a supervisor who decided to overlook it, made a judgment call, and said, let's not do it. Nobody really knows why it happened. The fact is it did happen, and it really could have had some drastic consequences. I'm happy to say nobody did fall using this anchor, so we really don't know for sure what might have happened, but we certainly can forecast. There's the adhesive anchor just for final clarity. Adhesive that's designed to be put into concrete apparently doesn't do very well when you install it into wood. So all of this goes to this thing that we call certification, and I'm going to talk more about what certification is later on in the webinar, but I just wanted to start with this little story about this stuff does matter, and bad things do happen if you don't pay attention, and if you overlook things, whether because you're intentionally don't care or you just don't know, and you know, ignorance is a fact of life, and so we want to try to learn. Bad things can happen, and so let's try to do what we can to avoid those risks. So the top 5 ways that we think you can reduce risk of fall-related injuries are shown here on the screen. And so we're going to talk about each one of these in some detail as we move through. Apply PtD, and that is prevention through design for new buildings and processes. Do a risk assessment the right way, and I'll describe what that means. Use less personal protective equipment. Now, I guess Josh, I don't know if I should have told you this earlier, that what I wanted to do is make sure everybody's aware that I'm not coming at this from a standpoint of selling equipment. Our LJB, we are consultants. I'm a structural engineer, certified safety professional. LJB does not manufacture, distribute, or otherwise sell personal protective equipment. And so sometimes people look at fall protection, and the first thing they think of is personal protective equipment. And I just wanted to make sure that everybody knew my perspective on this. And I'll certainly explain why we think personal protective equipment is not the panacea that everybody might claim it to be. Focus on certified systems, not just equipment. I'll explain more about that. And then last, certainly not least, provide general as well as system-specific training. So I will encourage you again, if you do have some questions that you want to post in, please feel free to do that as we progress. Number 1, apply PtD, again, prevention through design. So what prevention through design is really talking about, it's fairly basic. It's something that NIOSH, the National Institute of Occupational Safety and Health, has been developing and promoting for, oh boy, a good long while, 20 years. I'm not sure exactly the time frame on when that started. But the whole concept is fairly straightforward. You want to avoid introducing hazards into your facilities rather than trying to react to the hazards that we let slip by. So it applies to more than just fall protection, but since we're talking about fall protection, that's where I want to focus today. So on the screen you can see a couple of different buildings. So the building on the left, I think it's unusual, at least in my experience, to have a dozen or so air handlers this close together on the roof of a building, but I don't know, maybe that's how it's done in that neck of the woods. Regardless, certainly with that many air handlers up there, there's maintenance to be done. And what was done from a safety standpoint, whether that was intentional or not, we don't really know, and I suspect it was really unintentional, is you can see on this building there's a fairly high parapet. So now anybody working on those air handlers don't need to do anything to protect themselves from falling over the edge. All right, I mean, if it may or may not be, I can't quite tell if it's technically guardrail height, but certainly from a risk standpoint, the risk of falling over that large parapet is fairly small. Compared to the building down here, the illustration on the right, there's no parapet to speak of, and so although it's a big roof, you know, and maybe maybe if this is the roof hatch, people have to work on these air handlers. They're somewhat far away from the edge. There still is an exposure to falling over that edge, and so something else would need to be done, whether from some sort of temporary system or installation of guardrail after the fact. That certainly gets costly. And so the whole idea is it's a lot easier, better, cheaper, and safer to apply prevention through design and get rid of the hazards or minimize the hazards earlier in the stage or earlier in the process. And so the other thing I want to point out is it's not just about maintenance. If you're really doing prevention through design properly, you're considering construction. So is it possible to modify the design of this new facility so that, for example, the roof system can be built in modules on the ground and then hoisted into place? So it's those types of thought processes that need to be involved, and that's why that bottom point is so important. It requires a team approach. It can't just be a safety person getting engaged and saying, well, here's how you have to do it, because safety people don't know all of the ins and outs of the construction or the operations or the maintenance. And so on the other side, the folks who are building it don't necessarily know the safety piece. And so if you have that team and welcome the safety people to the table, but also the safety people welcoming the perspectives of the folks who have to own and operate the facility, and realizing that there are degrees of safe. I always actually say there's no such thing as safe. There's risk, and you can manage the risk, but you can never be 100% safe. And so as a safety professional, a lot of times I hear folks really criticize their managers who want them to, in their eyes, want them to make compromises with respect to safety. And what I try to counsel them is, look, you always are making a judgment call of how safe is safe. And so isn't it better to at least do something rather than nothing? Even if you can't get as safe as you want as a safety person, isn't doing something better than nothing? And so there's this art of compromise that we all have to live with. So the sooner the better in prevention through design, right? If you can eliminate if you can do it early and eliminate design costs or additional drawings or remobilization, basically anything that happens after the building is built is going to cost more than while it still lines on paper. And there was a study done many years ago to sort of validate that premise. And what this large manufacturing company they concluded is that for over here on the left-hand side, you see during conceptual design, if you were to invest $1 to address a fall hazard that you see during concept, let's say you want to install a new manufacturing line in an existing facility, but it's nevertheless a new line, similar to an existing line. And so now you have the benefit of knowing where the fall hazards are in real life, but on this new system that hasn't yet been installed. So if you can make a few changes to that new process, if you spend $1 doing that, then compare that to as you move through the process and you get into final drawings. Now you have to, there's more editing that needs to be done, but still, relatively economical. Now contrast that as you move farther along and you're into the field modifications. If they're now building this process, or just keeps getting more expensive logarithmically, during startup it's $1,000 to get that same level of safety, and then after the whole process is up and running, you have to spend $10,000 to do what you could have done for $1 back in conceptual design. It's actually even worse than that, because typically that $10,000 won't really buy you the same level of safety. For example, if there was a motor on the top of a piece of equipment that you knew had to get maintained, if during conceptual design you could have somehow relocated that motor to bring it down to floor level, well, after everything is up and running, the odds of you being able to relocate it just from a production standpoint are pretty slim. And so now you're probably looking at some sort of either an active fall arrest system, or maybe at best case a platform that is elevated up to the motor. Both of those abatement strategies are still less safe than relocating that motor to ground level in the first place. And so not only have you spent more money, you've not even achieved the same level of safety. So it's really what prevention through design is trying to achieve, is higher level of safety for less initial investment. So just a quick example, a real-life example of something that we were involved with. The before situation, it's an offshore oil platform that then you can see on the right-hand side some, I guess, BIM models of that. And so what we were doing was a virtual risk assessment, of, if you will, of this BIM model. And during that process, we discovered a few things that, you know, some equipment that needed to get maintained, and you know, obviously there are plenty of offshore oil platforms to look at in real life and to gather data from. So one particular item that we identified as a fall hazard, potential fall hazard, is something that is on a lot of different platforms, and something that once a month they would have to build scaffolding to get up and maintain it. And building scaffolding is not necessarily cheap anywhere you do it, but imagine on an oil platform offshore, everything is magnified, all the costs are magnified. And so when we discovered this fall hazard, and we made some fairly obvious suggestions, in my opinion, of how to do things a little differently, they implemented that change. And what they told us actually was that by implementing that one change over the life of this platform, they were going to save more money than what we charged them to do the design, right? So they more than recouped in just this one hazard, and we identified hundreds of hazards. In just this one hazard, they more than recouped any sort of investment they made in safety. And so it's just one example of how prevention through design can work, and it can help, and it just requires a little bit of change of attitude, and maybe a change of people to get the right people on the team. All right, so just a second ago I mentioned a virtual fall hazard assessment, and that's certainly one way. A fall hazard risk assessment really is, I guess in simplest terms, you can think of it as a list. And I'm not going to bore you with the details of my shopping experiences. Let's just say that the grocery store where I do sometimes stop for our groceries is enormous. It's this massive marketplace where even if you just want a gallon of milk, you have to walk through this, you know, 1,000-acre store, and you pass all kinds of different things that are distracting you, and a lot of times it takes me so long to get back to the milk that I don't even make it back there, and I go home and having not bought the one thing that I really need to buy. It's very similar to, you can definitely draw a comparison to a fall hazard assessment. If you don't have a list, a lot of times you forget the important things, you spend money on things that you really never meant to, and you're certainly not efficient because you wander around aimlessly looking for things that you think you might need. Same thing with respect to a fall hazard assessment. You're not aware of where all of your hazards are. You might be not abating the right hazards, and conversely, you might be abating the wrong hazards, I guess, and we'll talk more about that. And you definitely don't know when you're done, right? You don't have a way to sort of give you a roadmap, if you will, to say we should be investing our time and money on these particular hazards. And so as you consider what is a fall hazard, a lot of times there are things that are kind of obvious, you know, getting up to work in this power plant, to getting up to work on the this actuator, or access to the gauges, different things that might need maintenance on top of a piece of equipment. Some things you can see. Some things are a little bit less obvious. So here's some guardrail in an attic that's definitely not adequate. I say definitely because I'm trained in how to do this. I think a lot of people could probably look at that though and say, something doesn't look quite right about it. And the fall hazard, in case it's not obvious, this is just fiberglass insulation bats down through a plaster ceiling that anybody's stepping off to do work on the ventilation system, which we did actually see footprints on some of the larger ducts, so we know people did that. Certainly there's a pretty large fall hazard to look at there. Other things maybe are less obvious. definitely we can tell this is a fall hazard. This person doing, I think he's painting this roof. Certainly it's easy to see that fall hazard while that ladder's there and he's doing the work. If that ladder wasn't there and you were trying to identify fall hazards, is that one that people would necessarily get? I don't know. Or, you know, elevator shafts, right? A 16-inch gap down to an 80-foot fall. Is that something that ought to be looked at? The question is, which hazards should get our attention? And the things that we're trying to look at is really the risk. And risk for fall protection and fall hazards is really no different from risk of anything. What's the probability of an event happening, and what's the severity of in this case, the injury if that event were to happen? So what we're trying to do is gather all of the data about what makes it likely that a person would fall, and then look at the injuries. Are they going to fall into some sort of chemicals? Are they going to fall to a piece of machinery where they might get crushed? Different things like that impact the risk, and that's where the safety professionals can help evaluate that risk. But then the other piece is the whole relative risk, and how much will it cost to mitigate that risk, right? If all I have is just a list of items that need to be addressed, I really don't have any idea of which of those hazards are the ones that might pose the greatest risk. And so if I put this into sort of a graphical term, I guess I should say, in our experience, if we were doing a fall hazard risk assessment for, say, a 1 million square foot manufacturing plant, our experience is we identify about 1,000 unique fall hazards in that 1 million square foot facility. So, and some of them are trivial, some of them are kind of make your jaw drop that people will do that task. People will do a lot of crazy things for money, I think has been what I've found. But nevertheless, if we take each of those hazards and along the bottom graph that, so from the highest risk hazard on the left all the way to the lowest risk hazard on the right, and plot the risk of each of those hazards, it's not rocket science to imagine that what we conclude is sort of the 80-20 rule, right? In this particular example, this is a real study, I should say, so 20% of the risk of this particular site, 20% of the fall hazard risk was just in the top 1% of hazards, right? So a very high concentration of their risk just in very few of their items. Even more, 74% of the risk was just in the top 10% of the items. And then fully 96% of their total fall hazard risk was in the top 50% of the hazards that we identified. So if you have 1,000 hazards that you're looking at, you don't have 1,000 issues that you necessarily have to address right away. You've got, even if you just do the top 100, you've taken care of 74% of your risk, or you've certainly reduced it. Another way to think about that is the bottom 50% of the hazards in this particular example just had 4% of the risk. And so is that really a wise investment of your limited time and money to if you're trying to reduce the biggest bang for your buck, is that really where you should be spending your time? And I think not. So I think I'm just going to move on to, I was going to mention another story about fall hazard assessments, but I think I won't. Maybe I'll come back to it in a little bit. Let me talk now about PPE, personal protective equipment. I bet if I were to have asked at the beginning of the webinar that what do you think of when you think of fall protection, my experience is that at least 50%, probably 80% of the audience would say harnesses or lanyards or anchors or something related to personal protective equipment. It's just what's been ingrained in our culture for the past many years, 20 or 30 years, You know, when we think of fall protection, that's what people automatically assume we're talking about. And unfortunately, that it's not as simple as that. I wish it were. So there's a couple reasons why we recommend people try to minimize the use of personal protective equipment. I got to say, what I'm assuming is that if you're not going to use personal protective equipment, you're going to find another way to reduce the fall hazard risk. You're not just going to ignore the fall hazard. So I had been questioned about that once before, so I wanted to clarify that. So OSHA has stated, I mean, so if you need one reason to use less PPE, is a regulatory reason. And OSHA, in their standard directive 1-1.13, if you're keeping score at home, that's the official reference. They state that if you have a task that is performed frequently, and they define that as more than once every 2 weeks or more than 4 hours over a 4-week period, then you have to use engineering controls or a similar method to that, such as guardrail or an aerial lift, and that you can't therefore use personal protective equipment to provide protection for those frequent tasks. If you have less frequent tasks, then they give you that permission. But so here's one, again, a regulatory reason of why reducing PPE is a good idea. But really beyond that, and our philosophy towards fall protection and safety is, you know, OSHA, yes, that's the law. You have to do at least what it says, but it's really the bare minimum. A lot of people have been hurt or killed even though they are complying with the regulation. And so we think it's not that much more difficult to go above and beyond OSHA, and really following the ANSI Z359 standards is a good place to start for more information. But let me share with you some other reasons here that PPE is maybe not the answer that a lot of people think it is. Equipment misuse. I don't know the experience of everybody who's attending the webinar today, but my experience is that if you hand somebody a piece of fall protection equipment and don't give them any sort of training or education or anything about how that piece of equipment is supposed to be used, the odds of them actually being able to use it properly are very slim. It's just not intuitive. Whereas, you know, you give somebody a hard hat and you say, hey, we have a policy on our site that you have to wear a hard hat. It's a pretty good chance they're going to put that harness on, or the hard hat on properly, right? Fall protection equipment is definitely not that way. So what I've got to show you is, let me back up. So the video that I'm about to show you is a test of this wire clamp, and essentially it's intended to be used just as it's shown here around a pipe or some sort of horizontal structure, and you squeeze the handle here and it opens up, and then you can install it onto the pipe, and you know, here's your lanyard, and you can then go about your business. So just watch the video. Let me make sure, there's some sound here. I just want to make sure that, that the sound won't come through the webinar, but I'll just kind of narrate it. So this is the block that is falling, and directly behind the block is where that clamp is connected to this this structure. It's right at the intersection here. So just watch the video. So you can see it just kind of snapped right off, and here in a minute they'll show you the aftermath of what it did to that clamp. It's in pretty rough shape. So the reason this test was done is because not too long ago there was a fatality with somebody who was using a clamp just like this in a manner very similar to what you just saw in the test. They were climbing a tower, and although the person was working alone, so we don't know for sure, but the evidence has pointed to that this person had this wire clamp connected at the intersection of two members, and it side-loaded those wires and did a cause of failure very similar to that, and that person fell to their death. So it's unfortunate. I mean, the tragedy really could have been avoided if that person would have been using the right equipment. And I don't know about their training or anything other than that. I'm not trying to point fingers at anything other than the fact that that particular piece of equipment was not being used in the way that the manufacturer intended it. Here's another example. This is not a video, it's just some still shots, but this line here is the wire from a self-retracting lanyard similar to this one. I don't know exactly what model is being tested here, but this is the wire, and it's running over a beam edge, just a normal, untouched wide flange edge, steel beam. So here's the snap hook. You know, the snap hook that you see on the self-retracting lanyard. This is the one of the tests. There's a weight that's falling down here, and it's being pulled over an edge. And then in the next instant, here you can see the wire just severing, and it's instantaneous and catastrophic, and that person is now on the level below. It's not obvious that those systems are not supposed to be used over edges like that, especially actually the first time I ever saw, there's a video that goes along with this. The first time I ever saw the video, I was shocked because it's a wire rope. I mean, it's a 3/16 diameter steel cable that to pull on it, to hold it in your hands, it really feels robust. From just a strength standpoint, you really don't expect something like this to happen. And it does, and that's the problem. So even people who are trained in and experienced in fall protection equipment can be fooled. And so it's not people intentionally misusing equipment, it's just ignorance. We don't necessarily know because it's not intuitive. So that's certainly probably the biggest issue that I would promote as a reason to use less PPE. But beyond equipment misuse, just being able to identify a proper anchorage. I've heard plenty of people say, well, I only weigh 250 pounds and I'm anchoring to that steel beam over there, so I'm sure I'll be safe. Unfortunately, the actual anchorage forces that can be generated during a fall can be in the thousands of pounds. And so for somebody who's not trained or not experienced in identifying the proper anchorage or identifying the strength of members, to expect them to be able to do that and to know what the right magnitude needs to be, it's taking a pretty big risk. The same goes for fall clearance. I can't tell you how many times people have been using a system that I've seen, and they're maybe 8 feet off the ground, and they're using a 6-foot energy-absorbing lanyard that is connected around their back, you know, roughly at the level of their back D-ring. And certainly, if they were to fall, that lanyard would do them no good whatsoever. They would hit the ground, and they just don't realize it. They either don't think about it or they don't know what would happen. And so those clearances are oftentimes grossly underestimated. I mean, really, if you don't have at least 12 feet, 15 feet of vertical clearance between your feet and the ground, an active fall protection system is probably not the best answer for you. Incompatible components, we've seen plenty of opportunity where people connect snap hooks to shapes where the snap hooks could get side loaded or otherwise roll out of those connection points, and again, just not intuitive. It's not obvious how stuff is supposed to be used, and it all kind of, I guess you could summarize, it all points back to the improper training or inadequate training or maybe a lack of refresher training. Part of the problem is some of the folks that we're asking to use the fall protection systems, they only use it, you know, once a month, once every few months to do certain tasks, and so they forget. It's not like riding a bike. It's not intuitive. It's not easy, and so all those reasons really go to why we think using personal protective equipment as the first choice in fall protection is a really bad idea. However, I guess, so I should say, if you are going to use personal protective equipment, then we think it's a really good idea to focus on certified fall protection systems. And there's a lot of confusion, I guess, around the word certified. And so let me try to clarify that. You can have certified equipment. In fact, we hear that a lot, especially if people are familiar with horizontal lifelines. You know, a lot of the horizontal lifelines that you can buy, they're proprietary systems, and the manufacturers, they won't even sell them to the end user. They have to be only sold through what they refer to as certified installers. And I think that's great. There are some nuances about horizontal lifelines that the installation of those, again, it's not intuitive. You have to have proper training and know how to fabricate those pieces and connect them properly. And so to require a certified installer, I think, is a great idea. The problem is there's a misconception that if I have a certified installer of that piece of equipment, that therefore I have a certified system. And if the empty triangles on the screen aren't a clue for you, then let me just fill it out. That there are a lot of other factors to a certified system beyond just the equipment. And it really starts with, is this even the right solution to begin with? So if we've got a horizontal lifeline that's being proposed, say for example on a roof, but that is going to allow if the horizontal lifeline will allow it to deflect in such a way that I don't have enough clearance, say it's only a single-story building, for example, if I'm going to hit the ground while I'm using this horizontal lifeline, then that's obviously not the right solution. And so documentation that you've investigated the different approaches and looked at alternatives beyond just this particular piece of equipment, that's really where certification starts. The second piece of certification is identifying the anchorages and the clearance. So it's 1 and 2 sort of go hand in hand. You're evaluating different solutions, and part of the evaluation includes the anchorage capacity and the clearance, but it's the design that we're really talking about there. Certainly number 3, the equipment is a vital piece of it. If you don't have the right equipment in the system, then bad things can happen. And then the 4th piece of a certified system are the procedures and the training that the people who are going to be using the system need to have. And so all of these 4 components really make up a certified system, right? So don't be confused by this certified equipment and think that you've got therefore a certified fall protection system, because you might very well only have one little piece of the puzzle. The other piece of a certified system, in order to really have certification, well, let me back up. There's also a misconception out there that OSHA will either certify a system or requires a certified system, or at least has some sort of definition of a certified system. And all 3 of those things are false. OSHA actually doesn't mention anything about certification in the fall protection regulations. And so all of the information that we have, and what I'm talking about right now, comes from the ANSI Z359 fall protection code, and it's referred to as a code, but the ANSI standards are voluntary standards. You don't have to follow them, but it's really recognized as the best practice in fall protection, and certainly when we're talking about certified systems, it's really the only source of information that we have. And so the ANSI standard refers to a certified system as having a qualified person doing the design. And so OSHA does define what a qualified person is, and you can see that on the screen right now. Somebody who has a recognized degree or professional certificate, meaning they're not spelling it out. You don't have to be an engineer, a professional engineer, but certainly you could read that into it. extensive knowledge and experience in the subject field, and in this case we're talking about fall protection. And this is a piece that a lot of folks overlook. I hear a lot that, well, I had a structural engineer design my anchorage, so therefore I'm good. And I kind of look at it like this: well, you've got professional engineers, and we do the things that we do. You have safety people, so a certified safety professional, for example, does a whole host of different things. And where those two things overlap, one could argue that that really is the definition of a qualified person. And again, you don't have to be a professional engineer. You certainly don't have to be a certified safety professional. But if we're trying to minimize the risk and make sure you get the right people on your team, these are good qualifications to look for. And full disclosure, I am both of these, right? So I know there's a bias here, but nevertheless, this is it's sort of been borne out in the industry, and the ANSI standards really support this statement as well. When does certification need to be done? Well, it really sort of goes back to what are the pieces of it. So you've got definitely the design piece of it. So certification starts at the very beginning, and it really doesn't end. So it certainly runs through installation, but it doesn't end until the people are properly trained. The folks who have to use it are properly trained on how to use it. And then once a year, you've got annual inspection to do, and then every 5 years, a recertification. That what the point of recertification is really all about verifying that the codes and regulations haven't changed, or the conditions where the system is being used haven't changed. So for example, if there was a process put in place underneath where this particular fall protection system was to be used, if now you don't have the same fall clearance that you originally had, maybe that's a reason to modify the system. That's the kind of thing that you want to be on the lookout for on that 5-year recertification. And actually, that 5 years could be shortened in an area, in an environment where there are a lot of changes. So say, for example, at a refinery, things are changing all the time at refineries, and so that recertification, maybe it's every 2 years or even shorter than that. It's really up to the qualified person and the owner to decide what is the recertification frequency. The whole documentation, it's really where it all boils down to, that you don't have a certified system unless you have documentation for each of those different buckets that I've been talking about. The case study I was going to mention is really what I talked about at the very beginning, so I'll just kind of skip over that. Other than to say, if they would have applied the whole certification process and verified the installation, while it was being installed, this kind of thing never would have been permitted to exist. Not to say that it wouldn't have necessarily happened, but they would have found it upon some sort of construction inspection, or perhaps so on adhesive anchors, we generally recommend 100% load testing on adhesive anchors, not on steel-to-steel connections where you can visually inspect it, but on this particular installation, they probably, in hindsight, should have load tested those anchors as they were being installed, and then this kind of thing would have been discovered before it was ever put into place. Okay, well, the fifth thing that I wanted to talk about today is this thing, training. And what I'm really talking about, there are maybe three different levels of training that I think are important and are often overlooked. So the first level is authorized person training, and those are the folks who are actually doing the work at heights. Then there's the competent person training, and it's not, competent is sort of a capital C in this case. There's a definition of what a competent person is, and it's not just somebody who kind of generally knows what they're doing. It's a person with certain responsibilities. A lot of times the competent person that an employer will choose to designate are either safety personnel, or maybe they are the engineers who might be involved, Maybe sometimes there's supervisors who need to provide some support for the skilled trades or the authorized persons, but the employer gets to designate who the competent person is. And then it's up to that employer to make sure the competent person has the right training. So there's kind of three critical elements. This is probably true for any training, really, that you've got the content. If you don't have the content right, then kind of what's the point of the training? But if you don't deliver it properly so that people understand it well, and if you don't have an environment that's conducive to learning, what are the logistics, then the odds of that training being successful are pretty slim. And so let me just talk very briefly about each of those three legs of the stool. First of all, the content. Here again, we have to go back to the ANSI Z359 standard to get the best guidance, because OSHA just doesn't say a lot about what a competent person does, whereas the ANSI standard lists specifically 15 different duties of a competent person. You can see the reference to the standard right there. And so any training that you are considering really ought to address each of those 15 duties, and if it doesn't, then I would say it's not quite up to the level that you ought to be striving for. Same thing for an authorized person. The ANSI standard does give some description of what should be part of an authorized person training course. Just to give you sort of a feel for where I'm coming from on the duration and sort of the I guess the overall content of a competent person course, you can go online and find somebody who will say that they are providing competent person training in as little as 4 hours. You can also go, I think the longest I've seen is 50 hours. LJB's training that we provide is a 40-hour course, more like 36 hours, but roughly a week long. And we've tried to shorten it. We have shortened it on occasion for very specific conditions, but we found really to get through all of the material that ANSI recommends, it really does take that 4 to 5 days. And if you're doing it in much less than that, you're probably skipping out things, and you might be missing out on very important things. And so the 4-hour or even 8-hour 2-day competent person training, you should probably go back and review the ANSI standard and really consider, are you getting the information that a competent person truly needs. An authorized person training, on the other hand, the primary purpose of that is really to help the persons who have to use active fall protection systems to make sure that they know in general how to properly wear harnesses, how to properly inspect the equipment that they're going to be using, how to estimate clearances for the systems that they're going to be using. So those courses can go anywhere from maybe 4 hours to 8 hours. That's kind of a rule of thumb. And then the last bucket of training is what ANSI refers to it as system-specific training, and it's as obvious as it sounds. It's just training on the specific application, actually on site. So, for example, the horizontal lifeline system on the roof of a building, you actually go to that site and show people how to use that system. That can be done assuming they have already had their authorized person training. That system-specific training is 15 minutes, 30 minutes. It doesn't have to be terribly involved. You're just trying to show what is that system intended to do, what is it not doing that you might foresee somebody misusing it that way, and just kind of giving them a general overview on that. There's the book learning part of it, right? There's the academic background, we might call it, the program requirements, hazard identification, and this primarily we're talking about now the competent person class. And one of the reasons that the classes we think need to be longer than a day or two is because you really want to focus more on different hazard abatement strategies than only personal protective equipment. And so the things you can see listed on your screen there, the fall hazard abatement tools like engineering controls or proper use of lift equipment, And then certainly talking about personal fall protection, anchorages and fall clearances, that's got to be part of it too. So that was the book learning, but really an effective class, you're not going to get all of it just from a book. You're talking about equipment that is not intuitive, and so if you don't have some hands-on element, you're really going to be missing out on understanding what the proper use and limitations of those pieces of equipment really are. Delivery, again, is kind of an obvious thing. You need to have expertise in the subject matter. Really understanding the limitations of the equipment is the biggest thing that we've found, because people they'll find all sorts of creative ways to use a particular tool. And if you can't anticipate their questions and respond to their questions in a way that really makes sense to them, there's a good chance they're going to leave that training and use the tool the way they sort of think is best. And so if you don't have a properly qualified instructor, it's another challenge. Different delivery methods, definitely classroom time. Online time is appropriate as long as you combine that with the hands-on element, using different media to get the point across. Video, adult learners are different from teaching kids in school, so appealing to those adult learning methods is really important. Same with the logistics, and obviously, so I mentioned a week-long training. That can be a real challenge, getting people out of their work environment for 5 days. So you don't necessarily have to do that all in a single consecutive 5-day period. You can be creative about that, but just know that you need to be considerate of getting people in the environment to learn the best way you can. And I will close with the last little thing about training that I mentioned before. A lot of times people who are doing fall protection, they don't do it, if they're using their equipment, they might use it once a month, once every 6 months. And so they lack this whole repetition thing. And so let me just show you, just as you're watching this video, this has really nothing to do with fall protection, but just as you're watching it, ask yourself how many times it took this person to develop the skill that you're going to see in the video. So if I know it's a little grainy, those are bricks that they are lifting and now tossing. And there's always room for more, I think, is the attitude that I get from there. Right? There's still room. Yeah, give me some more. We can do it. Okay, that's enough. Now the best part is coming up. Again, did he get this right the first time? I think not. There you go. I guess there's the fall protection aspect to it. He made it across safely. Yeah, I'm just shocked. Every time I see that video, I just am amazed at the skill that person developed. And I'm convinced that it took a lot of practice to do that, just like it takes a lot of practice and repetition to really learn how to properly apply fall protection. So those top 5 ways, just in summary, we talked about prevention through design. We talked about risk assessments. We talked about using less personal protective equipment. We spent some time with certified fall protection systems and not just the equipment. And then this whole thing about training, the general and system-specific training. So hopefully a lot of those points can be taken back to your clients, to your workplace, and maybe help reduce that fall hazard risk. So Josh, I will turn it back over to you now, but we might have a couple minutes for questions. I don't know, I kind of ran up to the end here, but I'll turn it back to you.
Thank you. Yeah, we have one question. It's a two-parter. We'll try to get through this pretty fast. Just give me 1 second. It just jumped on me. Okay, it says, are there reliable global or national statistics about falls that cause injury? That's part 1.
Okay. Do you want me to answer part 1, or do you want to ask part 2?
Yeah, we'll answer part 1. And
okay,
part 2.
So part 1, I can't speak to global statistics. My instinct is that, yes, there are global statistics. I am definitely aware of the United States statistics, and those come from the Bureau of Labor Statistics, BLS.gov. and you can find a whole host of statistics all sliced and diced by industry and by maybe age of the injuries and fatalities. So and just in a nutshell, in the United States, the trend of fall hazard injuries and fall hazard fatalities since 1994, which is when the most recent fall protection regulation was enacted, has actually trended upward. So fall fatalities are actually on the increase and not the decrease. So it's not quite the direction that we want to see. Does that answer?
You kind of touched on the second half, which is, are these sorted or searchable as to circumstances, consequences, and steps taken to prevent future occurrences?
Yeah, so I don't think they get into, at least the statistics that I've seen, they don't really get into, how, they don't get into the details of how it could have been avoided. They tell you, here's the industry, whether it was from the construction industry or agriculture or manufacturing, it's that level of detail. It's not down into, well, this person was working on a robot in a manufacturing plant or anything like that. So unfortunately, they don't give that much information. The other, I guess, I don't know if this is good or bad, but the number of fatalities that we have to draw on are actually relatively few if you compare it to, say, like automobile accidents. That's the number one killer from a workplace fatality standpoint, is automobile. Well, falls are number two, but there are roughly 700 or 800 fall fatalities that are recorded in these statistics. And so we don't have a lot of data that we really can use to build our case for how to avoid them from a statistics standpoint. So we have to rely on sort of best practices and what we observe, near misses and things like that, which those are not recorded in the BLS data.
Great, thanks. If you could go to the next slide, please. I do just want to let everyone know that we have more webinars coming up. We have another one in 2 weeks you'll be getting a notice on. And these are some other ones coming up. And go ahead, next slide, please. There we go. I just want to thank everyone for joining us. And Kevin, thank you for a great presentation. You have a great day.
My pleasure. Thank you, Josh.
Mm-hmm.